questions into an example. Thank you. Whoa. Okay. Chrissy, how many cookies do you have in that packet?
6, you can get 2.
I know I won't take 2, that would be greedy, but I will take 1.
Yeah, great. Sure.
Yeah, I have 12.
Oh, nice.
Is there a breakfast?
Hmm?
Is there a breakfast?
No, I had breakfast. It's just, they looked so good there. Okay. So just to get warmed up, I want you to simplify the following, just to get us started. Simplify this. Into 1 fraction. Have you done that, KJ? Yeah? You have it simplified into 1 fraction? Yeah. Yeah, Monica? Yeah. Jerry?
Yeah.
Is that yes or no? Okay. So, Jerry, what did you get on the top here? Yes, you're Jerry, aren't you? Yeah, what did you get on the top? 5x plus 5. Did everyone else get that? Yeah, okay. And Jerry, on the bottom?
3x squared plus 7x plus 2.
Did everybody else get that?
No.
Yes.
Yeah, you got it? You got it, okay. So, I think we all agree going this way is easy. But what we will learn today is how to go this way, which is hard. In other words, how can we start here and finish up here? That's the process we're going to learn today. Okay? So before we jump into that, just a little bit of vocabulary. We call these problems proper if the top, which has degree n, and the bottom is degree m. So for example, if n equals 2, that makes the top a quadratic. If n equals 3, that's a cubic. If n equals 1, what's that? N equals 1? Oh, sorry, I meant to say m on the bottom. Linear, yeah. And if n equals 0?
Number.
Yeah, constant. Yeah. So we call this lesson proper because we just care about looking at problems where the n is smaller than the m, and that's important for today. These are called proper fractions, proper partial fractions. We want the top to be a degree less or more, the top to be 1 or more degree less than the, that's not a sentence. We want the degree on the top to be less than the degree on the bottom. Okay? So, let's see what we can do.
So what does this symbol mean? Double arrow.
Oh, if and only if. So in other words, Lee, it's proper if the n is less than m, or if the n is less than m, we call it proper, that they go together. Yeah. Is that weird Chinese thing from last week?
Mm-hmm.
Yes. No, 1 was enough, thank you. I much prefer these. Oh,
That's so good.
so ridiculously good.
Yeah.
I must taste. I must pace myself, maybe in the next class. Okay, so I have put together some rules to help you in this process. If you look at the example you just did, you can get a little bit of hints on how to go backwards. For example, if we started here, how might we get these? Factorize. Yeah. But then it's not clear how to get the top. Anyways, first we'll just start with the bottom, the factorizing. So, what could we say? Rule 1, I guess. I'll just write this as, we'll just say f over g. Okay, so what you have to do first is to factorize g. And we'll just say we'll just say g1, g2, etc. So this is over g1 plus this is over g2 plus this is over g3. Yeah. Second point is that the top is 1, and that's exactly 1, not 1 or more, exactly 1. Degree less than gi. And we'll call that fi. So f1, f2, f3, etc. So what do I mean by that? I'll give you an example. If this g here is cubic, then how many factors could we have? We could have 3 factors. And each of these factors would be a linear, and a linear. Right. What is the thing before linear? Constant. So this would be a constant, this would be a constant, this would be a constant. Okay. For example, if this is a quadratic, then the f would be linear. If this was a cubic, then the f here would be quadratic. So, do you understand? The second rule says the top is 1 degree less than the bottom. Okay? And the third and final hint here for these problems is that the number of constants in fi is 1, and again it's exactly 1, less than the number of constants in gi. Now, oh, there's actually a fourth rule, sorry. So the fourth rule is, how do you deal with factors that repeat? So for example, maybe G1 and G2 are the same. So what do? You shouldn't actually use both. Let me give you an example. So for example, let's say you have something, I'll just call it a thing, and it's equal to, let's say, the quadratic here is x squared plus 2x plus 1. Right, what are the factors of x squared plus 2x plus 1? X plus 1, and also x plus 1. Now, because this is a linear, what should we have on the top? A constant, so we'll say a, and because this is a linear, It should be a constant. But then you realise, oh hang on, this is stupid because these are the same.
Yeah.
So I can just write this as a plus b over x plus 1. But a plus b is also a constant. So you could have just written it as c over x plus 1. But that's stupid because that could never equal this. Because that's a quadratic and that's a linear. So what do you do when the factor repeats? So the way you deal with that is you have to square one of them. And then if it repeats again, then you would cube it. So if this was x plus 1 cubed, you would have x plus 1 squared, and x plus 1 cubed. In other words, if gi repeats, use gi power k the next time.
What does I stand for?
Just whichever one repeats. So like maybe it's the first factor repeats or maybe the second factor repeats. So for example, let's say you have something like g1, g2 and g3, but you notice that these two are actually the same. Then you should instead use g1, g2, g2 again, but square it. And if it repeats again, if the fourth factor is the same, then I would have to use g2 cubed. So rather than repeating the factor, I increase its power. So I'd go square if it happens the second time and cube if it happens a third time. You got that? Now, this page is very important because I don't actually see it explained like this in books. Like, I just made up these 4 rules from, doing this for 10 years. So I noticed with all these problems, you can take all the problems and boil them down into these 4 basic rules. So now we shall use these rules for a couple of examples to see how to do them. So we'll start with an easy one first. This is an example of what to do here. Tell me when you're ready to try a couple of examples. So we'll start with an easy one first.
Why?
Yeah, let's start with let's start with K. It's the same as A. Same difficulty. Okay, can I look at it now?
Yes.
Yep. Alright, so we have no, actually, let's start with A. The numbers are smaller. Minus 12 over 3x squared plus 8x plus 4. Okay, what do we have on the bottom here? Let's see. 3x, x, 1 and 4? No, that's not going to do it. 2 and 2? Yeah. Yes. Who's this now? I don't think so. Ah! Bring it in. Hey guys. I was just telling the students about this.
I get to read.
Oh, it's going to be great.
It actually should be fine.
Yeah, it's going to be great.
No.
It's going to be great. Is that okay? Yes.
Yeah, and don't worry about the packaging. I'll come over with Marius and
I'm sure they can take out the box.
yeah, but just about what's happened. The packaging is left over.
Yeah.
You really think it's going to be otherwise?
Yes.
So you're thinking then you'll be able to just have it up on the screen?
Yeah.
Like that?
Right in the corner. So I was telling the students that this might be the last time they see good old Acer.
It served you well.
It served us well, yes.
Yeah.
Yes.
Is that the really old one?
It is the really old one. Yes, it's
It's
still going.
It's still, to be honest with you, the resolution is better than the little one.
Yep. Yeah, but anyways, we'll have this now after lunch, hopefully.
Fingers crossed.
Alright, see you.
See you guys.
Oh, I see that you found your early man in the
I did find my early man.
There's at least one around. Oh, nice.
You're gonna put that or someone else?
No, the maintenance people will put it, and this is what I was saying, the wall mount. This will go on the ceiling, and then the monitor will hang from this, so you can turn it. Okay. Let's see. Now, if we follow the rules that I said earlier, this will equal something over 3x plus 2 plus something over x plus 2. Great, no problem. That's rule 1. What did I say in rule 2? The top should be 1 less than the bottom. So if this is a linear, on the top should be constant. So this is A, this is B. Rule 3, what did rule 3 say?
1 less than.
What's 1 less? The constant. So what I mean by that is here you have 2 constants and you have 1 on the top. That is good. Here you have 2 constants and on the, like, because there's like a 1 here, and you have 1 on the top. Again, that's good. And rule 4, not necessary because there are no repeated factors. Good. So there are 2 ways to solve this. I will show you both and you decide which one you want to use for the exam. Okay, so there's actually 2 methods here. Method 1, method 2. Okay, so in method 1, well, I'll just do method 1 first. Why am I splitting the page? You can split your page if you want, so you can see how long each one is compared to each other. So for the first method, what you do is you just multiply everything by these 2. So I won't write that down, I'll just write 2 brackets. So 1, 2, 1, 2, 1, 2. And you'll notice that this one cancels that one and this one cancels that one. This one will cancel the first one and this one here cancels the second one. So you're left with minus 12 equals, actually this is method 1 and 2. It's the same at the beginning and then it will split. A times x plus 2 plus b times 3x plus 2. Okay, so we get the split now. So this is method 1 and now this is method 2. So method 1 is the method I like. I'll do that one first. What you do is you expand this. So you have minus 12 equals ax plus 2a plus 3bx plus 2b. So you get minus 12 equals a plus 3b x plus 2a plus 2b. So if you think about it, that's actually me saying 0x minus 12 equals a plus 3bx plus 2a plus 2b. If I want these to be the same, I actually need a plus 3b, yeah, go on Sean, equals 0, and 2a plus 2b equals minus 12, or that can be simplified down into minus 6 here. Right, let's solve this. A minus a is gone, 3b minus b, 2b equals 6, so b equals 3, a equals minus 9. Now I said that's just one method. What's the second method? Well, what you do is you remember that this isn't quite an equals. In fact, it's something called an identity. Have I told you the difference between this?
Yeah.
Yeah? Do you remember what it is?
It can change.
Yeah, kind of. Like, for example, if I said x plus x equals 2, then you can get x equals 1. This is an equation. If I said x plus x equals 2x, this is actually an identity. Because you can't actually find x here. Although this is still true, you can't actually find x. So these 3 lines mean identity and 2 lines means equation. So this is actually an identity. Now what you notice that's useful about identities is you can use any x. Whereas with an equation there's only one, or well, maybe more than one x. So for example, it's still true to say 1 plus 1 equals 2, or 2 plus 2 equals 4, or rather 2 times 2, or 3 plus 3 equals 2 times 3. You know, that's still true. In other words, I can choose any x. Well, if I can choose any x, why not choose x equals, no, better than 0, better than 0. X equals minus 2. Because if I choose x equals minus 2, then I get minus 12, should be the same as b times minus 6 plus 2 minus 4. So then that means b equals 3. Well, hello, it's the same. And if I choose x equal to minus 2 over 3, then I get minus 12 equals a times, let's see, 4 over 3 plus 0. 36 over 4 is 9. A equals minus 9. The same. Thank you, Jerry. Thank you so much. Every year I ask students, your teacher likes this method and he doesn't like this method. Why? So Jerry, you are the first student to ever actually give me the reason why. The reason I don't like this method, as Jerry said, is because if you look at the original question, you're forbidden from using these values. You can't. Although, if you do use them, it still works. So I don't like this method because you have to use values you're not supposed to use, and using them is usually a problem, except here where it's not a problem. So I really don't like this method, although that it works. I much prefer this method, makes me happier. You can use whatever method you want in the exam, both are fine. There's actually a third method, but I don't want to show you method number 3 because the big disadvantage with method number 3 is it only works for a very small number of problems. So it's not, if you want to look it up, it's called the cover-up method. But be warned, it's for a very limited number of problems. So I prefer to show you these methods since they work for a whole range of problems. It's a bit like if you only learn factorizing to solve quadratics. Well, it works but for a limited number of quadratics, whereas the formula works for every quadratic. Okay, let's have a look at a harder one now, once you write this down. Yeah, take your time.
This one?
No, that's not. Not quite. Google it later. It's called cover up. Yes.
How do you come out with minus 12 equal AX plus 2B?
Minus this?
No, the first one.
Method 1 or 2?
Method 1 and 2.
Oh, earlier. Oh, how do I get this?
Yeah.
In the green, I multiplied my 3 fractions by these 2 factors. So it cancelled the 2, leaving me with just the minus 12. It cancelled one of them, leaving me with that. And here it cancelled one of them again, leaving me with that. In other words, I multiplied everything by 3x plus 2 and x plus 2. And Lee, if you're wondering where I got those, it's always the original denominator that you multiply by. Yeah. Yes.
What's the third step?
Third step?
Yeah.
Which method? Oh, you don't mean third step, you mean third rule. No problem, Jerry. Let's do an example now where we need to use the third rule. Let's see which one. Let's try H. Oh, by the way, you'll notice in D, E, F, and G, you have cubics. Can you see that? D, E, F, and G, you have cubics. Now, wait, calm yourself down. you need to factorize the cubics. In the exam, so far for the last 10 years, when they ask you to do this, they give you the factors of the cubic in the question. So for this lesson, if you want, you can use your calculator to get the factors of the cubic. If you're
all of that.
yeah. So what is it, mode 54 or something like on the Casio for the cubic?
Mode
Mode 50
Five.
something.
mode 5.
No. Well, mode 5 something for cubics. Mode 54. Mode 54, Jerry. Right, continuing. Can I scroll down? Okay. So, let's see which one I want to do actually. Do I want to do H? Yeah, I do want to do H. H is a good one. H is a very good one. You'll need your calculator. Let me open mine.
H.
16x cubed plus, oh sorry, thank you. 16x squared plus 65x plus 18 over 28x cubed plus 36x squared plus 15x plus 2 equals. So now we need to get our factors here. Equals. Okay, now let's see, is my calculator open yet? It's not. Chrissy, how many cookies have you left? Don't say 0. Oh, yes. It's so ridiculously good. Ridiculously good. Where the heck did you get them?
5.
Expensive?
No, it's like €2.
Respectable. Okay. If you don't know how to use your calculator, have a look and I'll show you. So Jerry,
I know.
press mode. Yeah. Okay, so the first one is 28 equals 36 equals 15 equals 2 equals. Right. The first factor is 7x plus 2. Happy with that? Yes? What's wrong, Sean? The next one is what?
2.
And the last one is, well, there isn't a third one, but it's cubic. So there should be 3. So what has happened?
Okay. Repeat.
Yeah, one of them is repeated. Now, if you think very carefully about it, you know which one is the one that's repeated. It cannot be this one. It has to be this one. Why? Well, if you think about multiplying them together, if it was 2, 1, 2, then at the back there should have been a 4. It has to be 2, 1, 1 because at the back you have a 2. So by thinking about it, you can figure out that it's the 2x plus 1 that's repeated. So using rule number 4, this next factor is what?
2 plus 1, 2.
Yeah. So far okay? Now, Jerry, if this is linear, what should this be?
Constant.
This one?
Constant.
Linear, very good. Now, let's have a look at rule 3. So what does rule 3 say, Jerry?
Should we write in this way, so we have 4 factors. Like 3, 2s plus 1, and 1, 7s plus
Mm-mm. It still works. You're thinking in your head, I know what you're thinking, but if I multiply these three together, I'll get a power of 4. In a moment, I'll tell you why you're wrong. Jerry?
Constant. The constant we have
The number, this symbol, number. Did you write that symbol down?
Yeah.
Okay. So, how many constants here, Jerry? 2. And how many here? 1. Here? 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 Aha! There's a problem. So, we have too many. In fact, one of these we don't need. Which one? Doesn't matter. Your choice. You can delete either of them. Which one would you like to delete? Yeah, make it a little easier. So it's just like this. Now, you might say, but I'll get a different answer if I delete this one. Correct, you will, and we'll talk about that in a moment. So let's delete the C for a moment. Now, Lee had a question, good question. If you multiply these together, you don't make a cubic, you'll make a power 4. But, if I just go back to here for a moment, let's just say this is something silly like ax plus b, and this one here is bx plus c, what am I saying, sorry, cx plus d, and then the last one we'll say is ex plus f squared. And we want to add these together. What power do I have here? Power... No, power 3, because if you look at you want to add these together, you would have to multiply the bottom here by cx plus d, and... But you know what? Maybe I could... sorry, apologies. It should be like this. Cx plus d plus cx plus d squared. Okay, so you'd multiply this one by cx plus d. You'd multiply this one here by cx plus d, and you would keep that the same. So what would you have now? You would have cx plus d squared. Here would be cx plus d squared. And this one here would be ax plus b times cx plus d. Okay, so they're nearly the same. What would I need to multiply now? I would need to multiply these ones by ax plus b. So I'd multiply an ax by b and an ax by b, and of course on the top as well. And of course I should have put the other ones up on the top. Okay, can I add them together now?
No.
Nearly. What about this guy? He's missing what? Another cx plus d. I'll put another cx plus d, and then on the top another cx plus d. So what I've done now is I've made a common cubic, and so I can add them together. In other words, because one of them is repeated, I can add them together in such a way that I don't need to make the extra power. So even though it looks like this might be a power 4, if you actually think about it carefully, you can put these together to make a cubic. This is possible to do. Okay, let us use method 1. So I'll multiply everything by these 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So all 3 cancel that. First cancels first. Second cancels second. And in this one, interestingly, second and third cancel second and third. So I'm just left with 16x squared plus 65x plus 18 equals A, 2x plus 1, 2x plus 1, plus B, 7x plus 2, 2x plus 1, plus D, the first one, 7x plus 2. Now, what values of x should we choose? Okay, firstly, let's choose what? What would be a good choice for our first x? If I wanted to find a, what could I choose for my first x? Yeah. Yeah. Oh, sorry, the three brackets that I'm multiplying are 7x plus 2, 2x plus 1, and 2x plus 1. In other words, Monica, it's the three factors that make this cubic. It's always the factors that make the cubic here that you multiply across by. Not this side, but you look at this side, and you look at the factors here and multiply across by those factors. They should always have the effect of cancelling the denominators here. Okay, so what should I choose for the x to begin with? Yeah, minus 2 over 7. And this I can get the a. Because this will be 0, and this will be 0. Okay, what should I choose next? What should I choose? Minus 1 over 2. Yeah, good. Because it'll cancel that, and then I can get the d. The d I can get. Right, now the last one's a bit tricky. Good, yeah. But what should I choose for x? It doesn't actually matter. What you can do is you can choose x as 0, but don't forget to use the a and the d that you've worked out. So if you look at this, do you know this? Yes. This? Yes. This? Yes. Do you know a? Yes. Do you know this? Yes. Do you know b? No. Do you know this? Yes. Do you know this? Yes. Do you know d? Yes. And do you know this? Yes. So you can get the b out here. Okay, so I want you to do that for me. I want you to get me the a, then the d, then the b, and see what you get. Yeah. No, I said you cannot use those, but strangely for this method, these forbidden values which you're not supposed to use, you can actually use them to get the a, the b, and the d. And this is why I don't like this method. And you might be saying, well, why are you using it? Because it's the quickest method. And in the exam, you don't have the luxury of time. This is the only exception for getting the constants in this problem.
And if a over 7x plus 7 and b over only 7x, then it should become 0.
Say again, sorry? Oh, you choose the x values to make zeros, yeah.
No, I mean, if the fraction below was like 7x, only 7x, not 7x plus 7, then the a will be like 5 equals 0.
Oh, if this was like 7x, then on the top you have an a still. Why would it be 0?
Because we have 7x plus 2, you said...
Oh, I'm sorry. Oh, I see. If this was 7x plus 2, it became 7x because this was 7x. Yeah, you could use x as 0.
No, I mean... The root 3.
Yeah.
The constant.
Yeah, the constant should be 1 less than the bottom.
Yeah, so now this is a will be like 1 constant.
Oh, I understand now. Yeah, sorry. This is 7x, and there's only 1 constant. So on the top there should be no constant. Although it's 0, 1 constant. Ooh, very interesting. No. You see, you almost tricked me. You didn't. If you have this 7x on the bottom, that is the same. That's 7x plus 0. It's still 2 constants. Yeah, just to be clear, KJ, what I mean by number of constants is like in this example, although this is squared, it's squaring only two. You only need two unique values to make this linear. To make your 7x, you need to have two unique values. You need to have a 7 and a 0. But if I had 7x squared, that's still two constants. So I need two constants to make this, a 7 and a 0. Yeah, good question. No one's ever asked me that before. See, you do this for 10 years, you think you hear every possible question, and some days are surprises. A 2x plus 1 squared. Is that right? 16, 65, 18, 2x plus 1 squared, 7x plus 2, 2x plus 1, 7x plus d. Okay, let's do this one together. So, Jerry, what was the first value you used here? For x, what was the first value used for x? Minus 2 over 7. Is that what you did first?
Yeah.
Okay. So, if I put this value in, did you get a is 4? Okay, good. Now, for the next one, Jerry, what's the next value of x to put in? Okay. Solve for, what's the next one give you? D, is it? Yeah. 7. Great. Now for the last one, what you have to do is put in A is 4. Then you also have to put in D is 7. Whoops. And then it doesn't matter what value you put in for x, so I'll just put in x is 0. And then you have something which has only b in it. So you can easily solve this for b. And you actually get b is 0. So they're the three values, 4, 0, and 7. So it means back in the question, this is equal to 4, 0, and 7. So in fact the middle one, we didn't need it to make the problem. Now you might be saying, well, I thought earlier we said there were two answers, and there are. If you look at the back, you'll see that there's two answers for this. Question, Monica? I thought I saw you put your hand up. Oh yeah.
If x is 0, then everything is.
No, I just think it worked out that b is 0 for this one. Let me have a look here. I think... Yeah, do you see that question number 2 there? The last question. I made that in such a way that the b is not 0 in the answer. You see you have 3 parts and one of them is repeated. Now, before we finish this lesson, I said there's 2 answers because you had a choice here. You can either change cx plus d into cx or into d, and we went with this, and by going with that we got this answer. So let's just check that this answer is right. 4 over 7x plus 2 plus 7 over 2x plus 1. Hey. Simplify basic, and this is actually the original question, although it didn't expand the denominator. 16x squared plus 65x plus 18. Now, have a look at the answer at the back. Can you read out the other answer that we could have gotten? What was it for h? 20 over 7 as like a coefficient of x? 20x? Oh, okay, sorry. 20 over 7x plus 2. 2x plus 1 squared. Now, if you look at this, I think we agree that answer is quite different to that answer. Like, just compare them. This 4 and 20 are different. And this is very different. This is a d, and this was a cx. This is a constant, and this is a linear. So you might be thinking, no way can these simplify to make the same answer here. Or, no, actually they can't. That's an 18 and 20. Did I write that down right? Or did I type the answer wrong? Oh, my heart. I must have typed one of the numbers wrong. This would have looked so much better if they were exactly the same. Oh well. That's life. Life sucks. Flip. Alright, let me just go back. Right, what was the thing I would have to change here? That D should be a CX. Alright, let's try this. Sub in X is minus 2 over 7. Whoa. Okay. Is that what I had at the back?
Yeah.
I had 4 over in my second answer. I thought I had 20. Yeah, so already I must have mistyped it. That perhaps is a 4. Let me just see what the B is. What should I put in next? Minus 1 over 2? Yeah, well that's fine. For the C, yeah? Okay, that's quite different. Minus 14. And then lastly, sub in X is 0. And sub in A is 4. And sub in C is 14. Is that what I had on my answer at the back? What did I have for A on the back, please? Did I? Oh, thank you. Maybe that's what happened last time. Okay. A is 4, and then C is minus 14. Okay. What was my answer at the back for A, please? Oh! I didn't type my B in when I typed in my 3 fractions. I only typed in the A and the... Yeah, okay, let's type this in now. 4 over... What was my first factor, please? My first denominator, what was it? 7x plus 2. Okay, and my next one was 7 over 2x plus 1. And my last one is minus 14x over... Okay, now, this time. Although, now this looks even more different to the first answer we got. Because our first answer only had 2 fractions in it. This has 3 fractions in it, and it's a constant linear, whereas the other answer we got, what was it? Constant and constant. Alright. Yes? Boom. Okay. I mistyped the answer at the back. So anyway, my point was, sorry KJ, my point is, taking both approaches gives you 2 very different answers, but in fact, both answers simplify down to the same thing, amazingly. Even though they look so different, you get the same thing. Quite amazing, I think. I would never have guessed that those 2 would be the same. Yes?
So we can have just one of them.
Oh yes, in the exam, you should choose the easier method. So I think everybody realised your life would be easier if you ditch the x part and just keep the constant. In the exam, sometimes they tell you which one to use. So they would say, write it in this form, and you would see that they want you to keep the x part and throw away the d part or whatever. But if they give you a choice, then you can choose either. Yeah? Okay. I'd say you'd want to take a little bit of a break after all of that, because this is all quite new, and then it gets harder. Yeah, why is this in the chapter with calculus? Because I think you would agree integrating these fellas are hard work, but integrating 3 simpler fractions would not be as bad. In other words, this process will allow us to simplify an integration down, which is quite difficult, into 3 simpler integrations.
Oh my god, what's the next one?
Yeah, the next one is, what's the difference in the next lesson compared to this lesson?
It's improper.
Yeah, but what about the question makes it improper if you look at them? Yeah, the top is the order more or the same as the bottom. Okay.
It's a similar method,
No, well, it's similar, but we need an extra step.
Yeah, but you still use like...
The concept is the same. Yeah. Okay, take a break for a couple of minutes. Monica, do you mind? No, I'll put the light on actually. Let me fix that disgusting mistake I made at the back.